This is for Year 12 specialists. It comes out of the Kinematics Forces topic test for 2021. And there's two multiple choice questions, question number 6 and question number 8. And the reason I'm putting these two together, because in both of them, we're told some information about acceleration, not constant. And both of them have to deal with what expression will we use for acceleration because we have because we don't have constant acceleration. So we'll go to the first question. A body is moving in a straight line in such a way that its velocity can be given by this. V squared equals 12 minus 4x squared. And I have to pick the graph for acceleration against x, acceleration against x, acceleration against x. So I need to use a replacement for acceleration. And what I'd like to use is this replacement for acceleration. And the reason I'm going to say that is acceleration equals d dx of a half v squared. And the reason I'm going to pick that is I can see my v squared. So I'd like to say a half v squared is going to be 6 minus 2x squared, and that d dx of a half v squared will be d dx of 6 minus 2x squared. The derivative of 6 is 0, minus 2x squared is minus 4x. So that's what d dx of a half v squared equals. And since acceleration equals a half, so d dx of a half v squared, acceleration equals minus 4x. Since acceleration equals minus 4x, if I'm graphing acceleration equals minus 4x, then I'm going to be choosing either this one or this one, depending upon what I have as a domain. And since I have nothing in the question that tells me that x can't be negative and a can't be negative, I'm going to choose D as being my option, because when x is negative, acceleration will be positive, and when x is positive, acceleration will be negative. And I can have x being negative because if this is my origin, x being negative is over here, and acceleration can be negative. It means it's decelerating, slowing down. Okay, so that's question number 6. And I used an expression for acceleration of this. If I jump to question number 8, a particle moves in a straight line with acceleration equals v squared plus 1 on 8. When the correct one decimal place, how many meters will the particle move from the origin when its velocity is 3? Okay, so I need to do a replacement for acceleration equals v squared plus 1 divided by 8. And since I need to find x at a particular velocity, I'd like to use x and v's, and I'd like to replace it with this. So dv dx times v equals v squared plus 1 over 8. So the integral, I'll leave the v here and the dv here. I'll move the dx over here, and I'm going to pick up the v squared plus 1 and leave 1/8 dx on the other side. So I've rearranged and I've used a replacement acceleration of dv dx times v. So I need the derivative of this, which is 2v, so I need a 2, so I'll balance that with a half. So I'm now going to have 1/2 log base e of v squared minus 1 equals 1/8 x plus some constant c. I know in this question that when the particle is at the origin, the velocity is 1. So when x equals 0, v equals 1. Okay, so that's a plus. That was a plus in the first place. So that's a plus. So a half log base c of 2 equals 0 plus c. So c equals a half log base c of 2. Therefore, I've got a half log base c of v squared plus 1 equals 1/8 x plus a half log base c of 2, which will give you a half log base c of v squared plus 1 all on 2 equals 1/8 x. By moving this to the other side, combining it, and with the negative on the logarithm becomes the division. What did the question ask me to do? How many meters will the particle be from the origin when the velocity is equal to 3? So at this point here, I'm happy to sub in a 3. A half log base c of 3 squared is 9 plus 1 on 2 equals 1/8 x. X equals, move the 8 over, 4 log base c of 5. And my answers are going to be in decimal places. So 4 log base c of 5 gives x equals, what was that again? 6.44, 6.437, 6.437, 6.4 will be my answer. I'm going to go for D as my answer. But to recap, because I had an expression for acceleration that was a equals v squared plus 1 on 8, and I needed to find x when v equaled 3, I replaced a with a substitution that involved x and v, and the one I chose was this one.